In this video, I'm going to be modeling for you or walking through some of the ideas we use in third grade when we're comparing fractions. So, when we're comparing fractions, we will notice that fractions are equal if they are the same size when we're using a drawing, or if they're at the same spot when we're using a number line. We will notice that a fraction is larger if it takes up a larger amount of space in a drawing, or if it's further from zero on the number line. So the further away it is from zero, the larger it is. And we will notice that fractions are smaller than another if they take up a lesser amount of space in a drawing, and if they're closer to zero. Okay? So I'm going to kind of walk you through what that might look like, and then we're also going to talk about one other step for comparing fractions. So here I have two fractions, 4/8 and 4/6, and I have made a drawing of each of them, and you'll notice that I made the holes as close to the same as I could because, again, it's hard to compare when the sizes are different. So here I have 4/8 and here I have 4/6, and I notice that 4/6 takes up more space in the hole than 4/8 does. So 4/6 is greater than 4/8, or 4/8 is less than. Here's another example here, 4/6 and 2/6. So I made a number line and I put 4/6 on the number line, and then I made a different number line and put 2/6. And I noticed that 4/6 is further from zero, 2/6 is closer to zero, so I know that 4/6 is greater than 2/6. All right, and lastly, I want to talk to you a little bit about another step that we use without visuals, about reasoning about the size of fractions using their numerator and denominator. So here I have a couple of examples here I'm going to talk to you about. So with these two, I want to compare them, and I can definitely use a visual model too, and I want to do that, but I also want to be able to talk through it and use a little bit of my common sense about fractions and what I know about them. So here, this fraction at 2/6 means that my whole was divided into 6 pieces, and I'm going to be using 2 of them. And this one means my whole is divided into fourths, and I'm going to be using 2 of them. So I notice my numerator is equal. Both fractions, I'm using 2 parts of it. But when I look at my denominator, this whole was broken into 6 pieces. This was broken into 4 pieces. And even though 6 typically is a larger number, when I'm using sixths, which is very different, sixths are smaller units than fourths. So actually, 1/4 is larger than every fourth is larger than every sixth. And remember, so that's like looking like this. Every fourth is larger than every single sixth. So I'm using 2 smaller parts or 2 larger parts. So because I'm using 2 larger parts, then overall 2/4 is larger than 2/6, because 2 larger units is greater than 2 smaller units. So here, I did use a visual, but I also used a little bit of reasoning about numerator and denominator. Or sometimes the third graders say I'm using my common sense about that. So let me look here at another one. So here I noticed that my numerators are different, but my denominators are the same. So here, both wholes were divided into eighths. So each unit is the same size. So now I need to think, I'm using 3/8 or 5/8. So the wholes are divided exactly the same. This one is partitioned into eighths, and I'm going to color in 3 of them. This one's partitioned into eighths also, but I'm coloring in 5 of them. So I'm going to use a little bit of my reasoning about numerator and denominator, a little bit about my fraction common sense to know that if I'm having more parts and the pieces are exactly the same, then more pieces is going to be an overall greater fraction. So 5/8 is greater than 3/8 because the denominators are the same, so I'm going to look at the numerator. Whereas here, the numerators are the same, so I'm going to think a little more deeply about the denominator. So these are kind of 3 strategies we use for comparing fractions. We draw visuals, we use thoughts on the number line, and then we reason with the numerator and denominator. For numerator and denominator, if the numerators are the same, I need to think about the denominator. And if the denominators are the same, then I need to think more closely about the numerator. All right, so use those 3 strategies when you are comparing fractions.